So what it does is there is a optimized version of OpenClaw called Nanobot that's built in Python. So I just worked that, tried to understand how everything's are working. And as you know, like OpenClaw is a very big thing, and it's super hard to like convert the entire thing into a different language in like a single day. And I also like learned Jack recently, very recently. So my plan was, what's Jack based at, right? It's a high-level abstraction programming language that has a like all the objects are acts as graphs, and I thought, why not use that potential and build something for memory abstraction. So the general idea is how Nanobot managed memory was SQL-like on local computer. Instead of that, what we do is have a graph-based memory architecture. Also, like you can visit the GraphClaw GitHub and download it. It supports Windows, Linux, Mac OS, anything. And after you install from the terminal, it should basically you can set up Telegram or Discord or whatever you want. Basically, just like a OpenClaw setup works. And what we have here is our GraphClaw dashboard, the control room. It's a bit different from how OpenClaw manages it. For us, all the you can see like everything here, all the name, identity, the soul, and all the details. But the different part here is the knowledge graph that we have that our agent taps into when answering a question. So for the root, all the most important stuffs are connected to this one. So this is the root. It has the soul, its identity, its name, and all the basic functionalities, the skills. So we have like skills. It's like not that much visible, but if you see the skills inheritance, like there are multiple parts of skills, right? The open registry where you can get skills. There is that. There is internal skill that I built for a Lovable and base 44 setup, and all these are directly connected and the most important parts of it. But as you zoom out, you see all the conversations that I had with the agent. And here, if I zoom in, these are like the random conversations that I had. These are assistant replies and what I say. And basically, what happens is the entire thing is filled with this conversation. And we have a dreamer that consolidates our the entire knowledge graph every 2 hours to make it smaller so that the memory does not increase over time to an extent where it is not usable. And also, we try to keep it as simple as possible. It's like it can be improved a lot further, but this is the best I could build in it there. Other layer of abstraction that help with our GraphClaw is the skills that we use. So the BiLLM function helps us a lot with that. So suppose I tell the agent, hey, build me a lovable website landing page for my friend Oyon for a portfolio, and it would just see what skills it has. Just call the BiLLM function, get the top 3 match, and tell me, and I would say, okay, use this and just build it. And if it like lacks the skill, if it cannot get the recall, it would just install it from the skills registry, which is basic OpenClaw functions. So it supports all the OpenClaw functions generally with the extension of the graph memory. So that's the basics of it. And I have a instance of this GraphClaw running on my phone. Let me just show you what it said. So here's the camera. Is it visible? So I just told you to say hi to everyone. So hi from my GraphClaw. Thank you. Are we allowed to take questions?
Yeah.
Oh, yeah.
Actually, yeah, 1 or 2 questions. Any questions from the judges?
So, yeah, it's a very, very nice project. You launched the repo. So the repo is now public and live open source.
Yeah, it's open source and public, and I would love if anyone would like contribute to the project because I wanna extend
Start a
it.
repo, yeah. Everybody can start a repo, contribute, yeah.
Can you actually post this to I built this in the Jaseci world?
Sure thing.
Discord, so people can actually, yeah, there are more people there, so they can actually, you know, help amplify it.
And you gotta blast it out on Hacker News and Product Hunt and all that. Yeah, you gotta, let's go.
Sure, why not? Just to add a little bit background context, one of my friends from Bangladesh actually built a graph memory layer on top of the Rust OpenClaw leak that got out, and it went like super viral. And graph memory can actually reduce the number of contexts that you use, so like help you save money, right? And everyone loves saving money. So I feel like there's a huge potential if we look into the graph memory architecture, and Jack can help with that.
Yes, awesome. Well, we're happy to also support projects and support open source development, so
Yes.
just keep in touch.
Definitely connect that. Okay. Any other questions? All right, thank you. Please go. Please go.
So hey guys, can you guys hear me?
You should use the mic.
Oh, you should use the mic. That's just what I could read.
That's
Oh.
what the video recording, yeah.
We're a group Civil Scope. Before we start, we also actually made a little post on LinkedIn if you want to check it out.
Hey.
Shout out. Our project is also open source, so like very welcome to join us on this journey. So yeah, I am Sean Dong.
I'm Sri.
I'm David. And this is our project Civil Scope. So what's the problem?
Everyone. So to introduce a problem, a crypto airdrop is when a project will distribute like free tokens to its early users. And so Sybil attacks are basically when attackers exploit this by kind of spinning up thousands of wallets, maybe doing a little bit of activity, and then they're claiming these tokens that should be going to actual new users instead of the same person. So this is a really big problem. So in 2023, Arbitrum lost 21% of its entire distribution to just Sybil clusters. And just weeks ago, a single operator used over 7,000 wallets to capture 40% of the robo airdrop. So it's not getting better, it's getting worse, and there's not a lot of products in the market that are actively addressing this problem.
So why Jack? When you try to build something like this in Python, you usually need to pull like multiple tools, like one library for the graph, another for AI calls, and format the data going into the model. But Jack is able to roll all that into just one language. So the way we thought about it, signal detection is really just 3 problems stacked on top of each other. The data is a graph, wallets is connected by transfers. You need to walk through that graph and compute signals as you go. Then you need to do something to reason about what you found. And Jack had a built-in answer to all that 3. So you want to, yeah.
All right, so basically what we used from Jack was the walkers, the by LLM functions, and the scalability of Jack. The walker is extremely important because we basically made the wallets as nodes and the transactions as edges. and Jack was perfect to use walkers to traverse those nodes and edges. We use a by-LLM function in order to make sure that we could call an AI like ChatGPT to analyze the connections between those nodes and using the connections from the walkers, traversing the walkers. Now, there are 3 typical types of attacks that are usually made by those Sybil attackers. The first one is a tree attack, the second one is a low vein attack, and the third one is a chain attack. As you guys can see, these are the 3 structures. And as I said before, Jack is perfect for detecting these structures.
So yeah, before we go into technical depth, we're gonna give you guys a real walkthrough of our demo. So yeah, this is the main page, and we scrape data from the Etherscan and Arbitrum. So there was a Sybil attack 2 years ago, and people get awards by exposing wallets that are evil. And we downloaded those data, and we were able to process them with Jack. And then here's what we are looking at. So each node is actually a wallet, and if we analyze, so the one thing about Jack is that Jack lets you send in the graph directly into the AI model, no prompt writing, no JSON formatting. So each cluster we have, you see on the right, it analyzes the cluster. It gives a confidence score. It tells you why does it give this score. And the red ones are the deemed evil ones. The white ones are the fund, where fund are coming from. And the green ones are the good ones. And the yellow ones are suspicious, sus. So we see different cluster, and one thing that we do is you see multiple people sending money to a single source or getting money from a single source. The purple line would be transaction, and the red lines are the fund direction. So with this visualization, we can actually see there's different patterns that we just mentioned here. And I think with this Jack analyzation, we also can get more about info about what judgment is made and what is the reasoning behind it.
Jack just makes it really simple for us to analyze all the data. So going on to the technical depth, as I've said before, there are typical types of attacks and structural signals.
Yeah, so we're basically it. We're basically done. So open to different questions, and check out our post and repo. Yeah.
Any questions from the judges?
Can you just go back to the slide with all the results?
Oh, okay.
Let's take a look at
The metrics, yes.
For this, so what was the data set you were actually using again for these metrics here?
So we
So we pulled the data of all transactions from Arbitrum, which was the token that we analyzed that airdropped, and then we also analyzed there was another one which verified another data set somewhere that verified all the malicious Sybil attackers, and then we combined the data between the data that we pulled from, we merged it to find the intersection addresses. So that means that if we analyze the data that we pulled from Arbitrum, we should get the intersected addresses.
Yeah, so the bad addresses that we got is from repo where people gets bounty by exposing wallet that they find are Sybil. And we grab those wallet address, and then we go to Etherscan to scrape all the transactions that will be analyzed and processed by Jack, which we also use to with the worker to build the nodes and the graphs. So we actually did a little bit of data processing. The recall here is we have a list of wallets where they are all Sybil, and we got a 96% rate of recognizing those are Sybil, actually evil.
And then the entire process for any of the agent questioning, all those for main here. So it's all done with GPT-4 main. That's the only.
All the analysis just
Is that for cost reasons, or it was just enough?
It's just.
No, that was the only
Yeah, we thought it's good enough, but furthermore, we're gonna try and make more different models.
It probably would have been like a lot more accurate if we used like the latest model, but we tried.
Yeah.
Very cool. Thank you.
Thank you.
Hijack is the next team.
Forget best name or.
Yeah, exactly. Yeah. And that's the clause actually. I know. That's very accurate.
I mean, working pretty effectively.
Yeah, work type of.
And I have you remember.
All right, you guys ready? Yeah, all right, let's go.
Okay. So we are Project Hijack. We won't know more before you do. So, open for and other on-loop agents have numerous ways of gaining context, and these are all the integrations that you can see. If any of you have used Composio, you know that there's like 500 different integrations. That might be something like Mail or like Telegram. Essentially, finding information about you. But I don't think I've seen one that taps into the one that's cheapest, yet the most intimate source of information about an individual. And that is something all of us carry around. That's your mobile phone. Most modern phones have like tens of different sensors. Location is the one, I guess, that's most frequently used. Most apps like location access. I don't see them using your accelerometer or like a gyroscope or anything else that's built into like an iPhone 14. So that was the idea. We created a mobile app with Jack that serves as an agent, but it gains context through sensors on your mobile phone, as well as other integrations to create truly intelligent automations. So creating a mobile app with Jack, that's not currently actually possible, I think. So we had to brainstorm. One way was to obviously like write it in a different language and pretend like it was Jack, but that's not possible. So we looked at some alternatives. We had a bunch of different cross-platform frameworks that compile to mobile while also letting you write web code. And we looked at Dolly, we looked at React Native. We also looked at this one called Capacitor, and that's the one we actually ended up going with. What we ended up doing was creating a new code space, which is called HJ for hijack. And what it does is essentially, it hooks into the compiler. We modified the compiler essentially, but it functions very similar to the CL code space in that it compiles a web, like a website, but in the end, we inject Capacitor to create Android and like iOS builds instantly. So yeah, you just write your same like Jack code. We didn't have to. I guess we had to make some modifications, but essentially it's still Jack. We didn't have to introduce any constructs to make this work.
And a little bit on the back end, we used backbone.io for a memory layer for the agent and in storage for database storage of the real-time events that we got from the sensors. So it collected data such as, I guess, rotation, movement, or location, etc. And it stored that in storage, and it used backbone.io as as inference and I guess agentic decision making based off those data points.
Yeah, I guess another thing is that the obvious structure to use for automations is the node system that Jack already has. So we have agents creating nodes that essentially result in automations that, like he said, that's stored in the cloud and that's stored by the agent. Yeah, I think that's it. So we can demo now. The app is on my phone. If you want me to show the build step on my laptop, I can do that. It's just we added the CLI flag, which is like -- Android or something. So this is the app. Oh, okay. I don't think you can. Okay. So can you reflect this? Oh, click on the camera icon. You're gonna have to take my word for it. That this just says hijack your day. And an example of an automation we thought of was to monitor for falls in alert emergency contexts. Because when like older people fall, or even people that have like motor disabilities, when they fall, they're not able to like attract attention to themselves. But everyone has their phone with them at like every single point in time. So this is an example. I just click on submit. This basically sends that over. Oh, it's already done, but basically sends that over to like another lamp, and that creates this automation, which is being stored in the cloud. So, Chuka, can you demonstrate?
I can get a
What? You didn't have to do that. Yeah. So essentially, what happened was that the accelerometer picks up on the fall and the fact that you didn't get up within a set amount of time, and then it like gives you this alert. Can you like? Yeah. Thanks.
It is spotlight on screen, I want to.
It's not another integration. We have like voice and like we have the capability to make more intelligent automations. Like for example, this. Okay, so essentially what's happening is it's taking my location from my phone and it's finding the nearest restaurant. That's something called downtown lunch. And it also realizes that Chuka is around. So it actually automatically created an SMS message saying, you want to join me for a quick bite right now. So I can choose to send this if I want to, but I'm not going to. Oh, maybe I will. Sure. Like that's an actual SMS, so yeah. This is it. I mean, we only showed off a small portion of the capabilities, but if you have a really nice iPhone, you can use, they have like 10 different sensors. So you could be driving home from work and have it like order you a pizza because it notices that your location is changing and like you're accelerating at like 60 miles an hour. So.
That's awesome.
Any questions? Okay, awesome.
Use backward and export, right?
Yeah.
You use that, this is, you could push one speaker, yeah. Yes.
Yeah.
So use backward and export, right? What should it use more? And did you get a chance to look at the repo for export and kind of play around with it?
So between the two, we ended up using them pretty much similarly. InStorage was mostly, I guess, in terms of pure like call requests, InStorage was used more because again, it is logging a lot of just raw sensor data. I guess you can thank Ron for the integration of the sensor data. But Backbone is essentially just used as like an agent decision-making layer. I believe that the information we went for was like maybe every few seconds it's running inference on the data that's logged. So.
Quick question for me, very impressive. I'm very impressed in 24 hours you built this solution and you upgraded Jack to target mobile, which is interesting, which is awesome. Congrats, kudos. I actually have a little bit of a curiosity. So I noticed you guys are using walkers in your code base. And I was just wondering, was walkers conceptually tricky to understand and utilize? It being a different kind of execution model than a typical function?
It was, but we showed up to like both the workshops, and I think they were like really useful in understanding them.
Okay.
Yeah, I wouldn't say they were too tricky to comprehend.
Cool. And do you plan to make a PR of
Yes.
of that mobile phone
Yeah,
picture?
Sure.
Yeah, even if it's a little dirty, it's a good starting place,
Okay,
right?
make sure it's perfect before we make it.
Jimmy wants to speak.
Yeah, so funny thing about PRs, I have a PR open.
Me too.
Yes, okay, we go back PRs open in JacHacks
Yes.
about 2 weeks ago. I haven't been merged yet.
Oh.
If you could give those a look, that'd be great.
Sweet. No, Discord. We'll figure it out.
We have
Discord.
it.
Yeah,
Yeah,
we
like we made a website changes and stuff because like it wasn't mobile responsive, and then we just got ignored.
Oh.
And then they got.
That's a, yeah. I dropped the ball there, my bad, guys. All right, I'll get on it.
Next to you is Polywatch.
Is it ready?
Figure everything real quick.
Okay.
There's 2 microphones, can you put one on? Little square pins.
Are you guys ready?
Yes.
Okay, no rush.
Alright, yeah, because my name is Adam Presley and I'm here with Polywatch, and we basically built an analyst best friend for detecting insider trade. And essentially, the major problem with this is with crypto and crypto markets, it's become really hard to track things like insider trading because it's so fast, it happens right away, and it's at such a large scale, and it's basically impossible to track now. Here's a case study that we ran with our program, and you can see there's a lot of money that went through and went through very quick. One of the main predictors for this is the time frame at which the trade happens before the news outline comes. And yeah, you can see a lot of profit was moved. Yeah, and once again, detection is very difficult because it's very complex, it's very fast, and it's just hard to monitor.
So to build our solution to tracking insider traders, we built a tool that uses a tree of thought reasoning algorithm to run a complex search by using data analytics functions that we programmed. So tree of thought is an algorithm developed by researchers at Google DeepMind and Princeton. And essentially the idea is you are acting like an investigator, right? So a detective is going to think, hey, this guy puts $10,000 before the news came out. He might be suspicious, right? He might be an insider trader. There would be a different investigative path. Maybe maybe there's a cluster of similar traders who are collectively sharing information. So our tree of thought reasoning algorithm allows us to essentially go down rabbit holes and do research paths, sort of like a real detective would. And we implement these into JacHacks by using walkers, nodes, edges. It works so perfectly. It works so well. Like, if the researchers at Google DeepMind and Princeton knew about this, I'm sure they would love to be using it. So we use the walker traverse to traverse and arrive at nodes. And when we arrive at a node, we use special LLM functions We renamed ours to DeepSeek LLM because we like the token savings. Yeah, that's how the algorithm works. Thanks.
All right, time for my favorite part, the demo. So how many of you guys have placed like a bet before? Or maybe traded online? Well, there's this like app or website named Polymarket. You guys heard of it?
Yeah.
Right? And specifically this one that we mentioned earlier, somebody made, how much was it? $400,000, right?
30K investments.
And that's kind of ridiculous, right? And we want to detect that before these kinds of like trades end. So if we head over to our app, we can search up for any market name. So let's search up Maduro, right? We won't search up the exact market name because now you get to choose. Let's search the top one, right? Here, you're going to see the overview. It'll show you in general how many tool calls is doing, how many LLM calls is doing, how many pieces of evidence is confirmed that is useful, and how many articles it finds. So if we head over to the tree, you'll see it'll first start at the root. So it's trying to see where we're going to start, what we're going to first call, and which path we're going to go down using that tree. First thing it usually does is look at the physical timeline. You can see, you can click on any of these news articles. It'll take you to, we use Google News because it's free. And, well, these aren't free, they're just paid, but you can click on any of them. You'll be able to go to evidence. It's the all accepted. If you click on it, it'll give you more information on it. You go back, you can go to the report. That isn't generated until once like the whole thing is done. Here you can see exactly what it came up with, what it found, and if you click on these instances, it'll tell you all the data about it. Like 22 of them, it references what it talks about earlier in the sentence, and it gives you all the information. So officials can use this as an insider, right? And if you go back to the overview, at the end of the whole report, you'll be able to see the confidence verification, the full investigation steps, this automate like all these slides. So you can watch what it does and what it finds. At the very bottom, you'll see the wallet prices, the price history, and then the daily trading volume. This one is at 400K.
So the very last thing is, I know my other colleagues talked about it, but who is going to use this software? We think not only is this a great tool to use for these online platforms like Polymarket, but we think this is even scalable to things like governmental institutions, places where, you know, people may have access to things that the normal population isn't privy to. So we believe that this is a great tool that we can use for the future.
Any questions, guys?
Any questions?
It's an impressive live demo. Do you guys plan to launch this?
We've been thinking about it. We're not quite sure because we just coded this last night. But we're still trying to evaluate this go. We're trying to think of like who would most benefit from this. We're thinking Polymarket. They've been looking for solutions for a while to detect insider traders because this is difficult with the anonymity on the platform. So we've been thinking about direction we go to.
And adding on to that, I want to just say, you know, we don't want to rush this either. Because the thing is, right, is even if we think we have a solid solution, we don't want to be the ones to be the bad guys and start accusing people who haven't done anything to start being like, you've been insider trading, and they've been making just random bets that seem to correlate. So we want to thoroughly vet every single test case, even have outside sources come in and analyze it securely.
Any other questions?
Cool. So I saw you guys look through lots of like news source. I'm wondering, do you guys have a different reads on the source, like where it came from, and then which one should you read more to make the prediction and the guess?
So we let the LLM reasoning process take care of it. So it sees all the information, and when it arrives at the node, it can make a decision about how to branch off and choose that information. So maybe it sees one news article about information being released, right? Like let's say with the Maduro capture, it's the news article about him being captured, right?
that is going to probably change the market really quickly, right? So the LLM reasoning process is probably going to make more branches looking at that news article and querying that news article for information, as opposed to doing that for all of the information. So we don't really have a weighting process in the sense that we have a different machine learning model creating physical numbers. It's more creating the next node or the next edge link to manipulate and query the data, if that makes sense.
So like you have a branch, as you can see, this lower purple one, and then you have many leads that it'll test for. And then if it's not conclusive, it'll go back up to the previous branch and then keep going.
Interesting.
So it's kind of like an investigator. They're not mathematically wrote down. I'm 98% confident that this path is going to lead me somewhere, but it's just not going on the vibes mostly, but also evidence. Make sure the evidence is visible to the user and visible not.
It's a very interesting new subject. Thank you.
Thank you.
I guess kind of the students that startup.
I mean, I would say absolutely. I think there's, you know, whether I like to think I'm greedy or not, there's money to be made in this market, and so I think it's totally on the board that something like this could be used towards the future, and we're totally all into and active in pursuing something like that.
Let's thank the speakers again.
The next one is Jack in the Box.
Oh, got it.
Hello?
Oh, I got turned on.
Hello? All right. Good afternoon, everyone. We're team Jack in the Box. My name is Kuldeep, and I'm here with my amazing team.
I'm Adam. Juna. And I'm Krish.
Yesterday, we heard from Dr. Mars that Jack was built for everyone, including our parents. That mission stuck with us, but when we actually sat down to learn Jack, we had a few errors. Can I get a raise of hands? Did anyone have initial issues just learning Jack? Okay, let's make sure we're not alone. No edges, walkers. It's a brilliant model, to be frank, but right now it's a little invisible to me. I would like to see something physical, maybe a graph breathing, or I just have to hope that my code is right. Obviously, you can throw your code in like some AI chatbot, you know, Jack Builder, Claude Code. Unfortunately, I don't have credits, but that's not about learning Jack, right? You're depriving yourself of critical principles of, you know, and just outsourcing it to like something else. We believe the Jack ecosystem will only grow as fast as people can visualize it. We realize that Jack can truly be for everyone, but it needs a bridge for these younger, curious beginners all the way to these professional developers.
Yeah, and we just see by the show of hands, like there's a lot of people who struggle to like just to get to learn Jack. So we found out that there's not a lot of like beginner-friendly tools out there for Jack. So we came up with a solution. We came up with two solutions. So the first one is it's basically a scratch for Jack. So it allows like for beginners to just play along with blocks and get the hang of it. And the second one is we also developed a VS Code extension that links and debugs for Jack. And yeah, we'll just change the cut and show you the demo.
Yeah, so let me take you guys through this scratch demo here. I'm super excited about this, one of my favorite things I've made. So I know we're all like, CS majors, coders, kind of geeky. So I know a bunch of people in here are familiar with this. Basically, this is block coding, right? So we've taken, blocks of JACK syntax that collectively exhaust the entire library. And basically, you're able to put these blocks together, and in real time, we'll see code here on the right updating. So let's go ahead and make a very basic JACK program. And if you pay attention to the right, we can watch as things update. Let's do this. Get one of these. Rename that. And we'll add connection. And we'll be able to go ahead and run this on our platform. And what we'll see is that we actually have a visualization of how the nodes work. Now, I can build you guys something way more complicated by hand, but that's going to take a while. So I put together some more sample blocks here that we can go through. Now, obviously, just the graphs are pretty complicated to on their own, but what's more complicated is the Walker traversal. So what we've done is we've also added a little follow along with Walker traversal when you run really complicated programs like this. So let's go ahead and run this and see what that looks like. And keep in mind, this is 100% accurate to the syntax. And obviously this isn't hard coded. If I go ahead and move things around, it's going to update in the code there. So, yep, that's our Scratch editor there. And Chris, you want to take it?
Yeah. So this next part might not be as interesting to you guys. Actually, I don't use a MacBook, so it's open the VS Code for me. Thank you. But yeah, we basically built an extension to lint, debug, etc. So while we were building this last night, we got stuck with like errors and stuff, so we didn't know what we were doing. So we thought, why not build something that everyone might use? So we went around, talked to a lot of people, and they said they'd use something like this. So here's our demo. So this is the first part that our extension does, is linting. So as you can see, there is no semicolon here. So this error is thrown. If you add a semicolon, it's gone. Perfect. Second, we have pretty print basically. We have like white space here. We have some semicolons missing, which is a Command-Shift-P in format document. It's perfectly formatted. All our errors are gone again. Thirdly, we added autofill features. So let's say you want to create a by LLM call. So you do this, boom, it's autofilled, and you can continue coding. You can also do stuff like Walker. Sorry. Yeah, and then the fourth one, the last feature we added was a transpiler. So we can go directly from JACK code to Python code. So it'll generate over here. And we can give the same output that the JACK code would have given us. Yeah, that's an extension, guys. Pretty cool stuff. This is actually live on the marketplace. So if you guys, any of you guys want to use it, feel free. In 24 hours. And lastly, we're also going for the video tracks, so like the YouTube and the Instagram tracks. So scan our link and go to the YouTube video. We've actually done something. I think you guys are like, I don't think we're planning to demo it right now. Unless you guys want to see it, then I'll show it to you guys. Like and subscribe. Thank you guys. Yeah.
Question. So remember who created the GoFundMe?
We don't know what you're talking about, but
GoFundMe is using the hackathon, potentially. You stressed a lot of people.
When you created all the Scratch block, I mean, you covered all the syntax, right? So how did you, did you automatically generate with using models, or did you have to manually sort of make sure create a specification for all the syntax?
Yeah, so Google, they actually, I love how these big tech companies have like these very small open source projects on the side, because we get to do cool things with them, like what we just did. So Google has this open source project called Blockly, where they've created this modular, JavaScript framework basically, where they have like complete mutually exclusive, collectively exhaustive block coding for Python, JavaScript, and a couple other very popular languages. but they've made it very, very modular. So how it works is you have these blocks and then you have a generator which changes like these blocks into the actual code. And so all we had to do is change, obviously add the logic for each of the Jack, all the Jack syntax. And then we had to make a Jack generator from a JavaScript generator, which was, pretty straightforward for the most part. It can be like automated with an LLM, but I think there's a little bit of novelty with having to go through and kind of get an implicit understanding of all the Jack syntax on our own in order to make that work. Additionally, part of having graphs displayed within the Scratch thing that we had is we had to use like the print graph functionality in Jack because that's how you get like the DOT and the graph data. So kind of written inside our code is like small lines of Jack in order to extract what we need to display it there. So yeah, it's to answer your question, open source model, very modular. You can kind of just work off of it.
So is the Scratch Builder, is that available now?
I don't know if it's public, but it certainly will be after today. It's not already. So
Push
yeah.
it. I want to actually give it to my kids tonight.
Yeah, it's
Right?
great for kids.
That's a really powerful tool. Like, this is phenomenal work, and I love the impact-driven way that you chose to work on things to improve the ecosystem. Like, that's awesome. And so, kudos on all of that work. Yeah, so we should connect.
Thank you so much.
Actually, it is up on the website, just that the Walker feature isn't working since that's running on a local backend, but the website is up, so you can go and check it out and then run through it.
All right, good. Put that in I built this for sure.
Of course.
Yeah. I want to see it. I want to play with it. I'll enjoy that.
All right, thank you guys.
Awesome.
Thank you. All right, the seventh team is, wait, no, it's not the seventh team. The next team is sixth Sense.
You just have to go search for it. The best dress would work.
I know. We need the best dress.
Golly.
All matter in this? Well, no. Definitely not. Are we connected?
Oh, no. It's right here.
Okay.
Here. Trying to get the slides right now, yeah. Right.
Are you ready, guys?
Yeah.
Imagine a world where you are just simply, just with all your ideas and innovations, and it's just simply hard to express yourself and get the words across the table. That's where Sixth Sense comes. Well, I'm Raj Roman, and I'm from 9,000 miles away, and I'm a mechanical engineering student. On my third year, I declared psychology to be my second major. And lately I completed a communication minor, so that's one thing out of the way, 2 more to go, and I'm here for a while.
Hello, y'all. I'm Edwin Goswami. I'm right around here from Michigan, from Troy, and I go to UMich, and this is my first hackathon, so I'm really excited to share what I have.
Hi, I'm Aryan. I'm a freshman at Michigan's majoring in computer engineering, and I'm from Cleveland, Ohio.
My name is Param Natu. I also go to the University of Michigan. I'm also a freshman, and I'm from Dallas, Texas.
So before we go into it fully, like the actual problem, I'd like to share a story. All right. So at one point I was actually bullied by someone, older than me, and at the time I was very mad. But then I realized that he just had a different way of expressing himself. It turns out he had Down syndrome. And genuinely, that made me feel like part of it was no one would interact with him. Everyone would think that he's the problem, he's got some issues, and would treat him like a sensitive being when no one would really make the actual cause to talk to him. And so, if there's two things I want anyone to walk away with today, it's that it's not mentally disabled, it is differently able. And the second thing I want everyone to go with is that us at 6 Sense want to bridge that gap and to really help people express themselves, as my friend Rahman said.
So what does 6 Sense do? It just simply articulates whatever it's seeing live. It's giving you live interaction feedback where it's seeing the other person in front of you and trying to recognize the social cues, trying to read the room. How could it be better? It just suggests the interaction so that it's just malleable, just normal. You can communicate better and simply express yourself.
So who is 6 Sense for? 6 Sense is for people who are neurodivergent and for the differently able as well.
Rather than anyone who is like very anxious and who can't really express themselves. We want to give whoever can express themselves a voice. Everyone's voice matters. That is our goal here at 6 Sense.
Even if you are the perfect man for this, you need it too, because actually understanding what is the other person going through or learning their emotions, social cues, and just like things that are they crossed hands? Are they tensed? Are they emotional? What's their emotional state right now? So seeing it live feedback on your glasses or website or cell phone could actually help you improve your conversation. And we're gonna be having a live demonstration, and we would request one of the judges to be our demo. Would anyone show up and participate in our demonstration, please? Thank you so much.
Alright, so, come over here.
So before he starts, I want you guys to see the tone. I want you guys to see the eye contact, expression, delay, and underneath over here, you're gonna see the suggestions. So AI helps you to just communicate better.
Do you want me to say something?
Yeah, please. Test it out.
Okay, so we had a pretty long day today at JacHacks. Very tired. Yeah. I can change my tone now, I guess, right? So
What do you do?
This is the most insane hackathon in 2026.
So stressed.
There's a delay, So.
And if you tilt your head a little bit like you're confused, you can actually show that. Here, if you get looks in your dog. See, it's tilting your head. See, there's a little bit of a delay, but it can show you in real time what you're doing, and this is helpful for people.
As well as we would like to give a demo with our participant who actually knows what to say.
This homework assignment.
Look at the demo.
So stressed. So as you can see here, I got eye contact. They appear to be confused or less connected to the conversation. So that shows to the person that maybe this is not the best time to say something. And this is really good for people who lack these kind of social cues. And it'll help them understand better.
And integrating it with Meta glasses or any cell phones would actually give you live feedback in front of the individual. Simply.
Cool. And so, yeah, that's sort of our little demonstration.
We would like to answer any questions, concerns, comments, any observations, and constructive feedback is more than welcome.
And so let's hand it over to Laurie to explain a little bit about how we used.
Okay, so Jack basically is the glue that holds 6 Sense together. So we use it to set up the server that integrates the front end and the back end of our product. And Edwin can go into a little bit more detail on the specifics of the backend.
So if the Jack is the glue behind our entire thing that's holding it all together, Jack is also the part of the front end when it is deployed. It's very important for deploying, and it would never be possible without JacHacks. So I really thank everyone for making this possible for us. But for the heavy LLM-based stuff, unfortunately, we actually found out when this guy can talk more about the base 44 stuff, we ran out of credits. So we had to do everything ourselves. Even like the voice stuff, I had to use my own voice, different modulations. I believe I talked to this gentleman earlier regarding it, and it was like very hard. We stayed up till 7 doing this, and it was, I didn't get any sleep. I don't think these guys got much sleep either. And it's just, there's so much stuff in here that's just very different. Anyone can create something that can recognize somebody's face, but what I realized is that tone makes the difference. And so that's why I focused a lot on that tonal analysis.
This is checking thousands of pictures and comparing with those pictures live, hands-on, just to compare the feed and understand what is it actually going through, what could be the emotional face, facial expression. Jaseci actually helped us where we actually encountered problems, and the AI chatbot, oh my God, that thing is a lifesaver. That helped us debug anything that just we ran through and just it wasn't deploying anymore. We had to retell it that, oh, we want it just like this to happen. And it articulated just like we wanted it to happen. Within 24 hours from idea to execution, JacHacks and JacHacks helped us. Jaseci company and JacHacks helped us to get our ideas to the table, and it's in front of you. Thank you so much. I'll take your leave.
Yep. That's all, folks. That's the or anyone wants to come up and do the demo as well. They're welcome to come up.
So, question, how does it actually work? So, there's a couple of inputs here, right? You have the video, and then you have the text, and then there's the audio. How are you aggregating all of that to, that kind of dashboard?
Okay, so what we're doing is we're actually using the connections and the, if I go into the actual file structure here, sorry, it's just gonna take a moment. The services, right? If you go to the 6th Sense SV.Jack, that's where the entire integration happens. It's all the services, all the, if you want me to pull the code. I'm so bad for this, I don't use a compiler. I just go into Notepad, I ask there's something wrong. So here is where all that stuff happens. As you can see here, eye contact low, expression confused. The entire thing that's happening right now is it's taking these different data sets and different, things that go through LLMs. It processes it using these services. In effect, that provides the entire output, right? And so I guess I was explaining this earlier with this. I actually really love talking about the voice thing. I actually use my own voice samples. It would take the wave file, it would turn it into, from an analog wave to and digitally, and it would take those different digitally, and when you talk, right, there's different modulations how you talk, right? There's different in frequency, and when you're, stressed, when you're calm, when you're doing certain things, and you're not certain about certain things, and those things, sort of get you.
Thank you so much.
Yeah. Well, yeah.
All right, thank you.
Sorry.
Yes, yeah.
I really.
Yeah, I have another question.
Oh,
Do
yeah.
you guys use any CNN type models to process the base data, or is it purely?
Facial recognition.
We tried to use CNN, but it just simply didn't work. We tried to use a different version of OpenCV to sort of help us.
Maybe Ghost Watch can set it up while they answer the questions.
Of course, you're more welcome to. Of course,
Feel free to catch up later.
Sorry, different headspace.
All right. You ready? Turn it on, yeah. Flip it the switch. There you go. Oh, yeah, there you go.
Okay. Hi guys, I'm Ayush and this is my friend Aaron and we're here to present Ghostwatch. We're an autonomous code defense structure with graph native clarity for your open source repository. So a little bit about myself. I've been contributing to open source for about 3 years now, and some of my main contributions have been to Django, PyTorch, and React. And currently, I'm working at a YC company, open source contributing to the ML compute systems. As such, I've found a lot of problems with the open source community that I wanted to solve with Ghostwatch. I wanted to read some of them to you, like dependency and log file changes through reviews. So reviews miss what actually shipped. If you guys know what happened to Axios for the npm install issue with the malware from I think 1 a.m. to 4 a.m. UTC last week, it was because of this issue where reviews just missed the malware that came in because it's all just manual. 3 more problems that I did face was when a package changes, the blast radius is unclear, which files, tests, and entry points actually depend on it. And there's also PR review fatigue that turns real risk into background noise. And then urgent signals look like every single other comment instead of, pushing for more urgency on them. And then last but not the least, a single malicious or compromised dependency can hurt users' org reputation and on-call, not just for the security team. That's why we built Ghostwatch. Let's get started. So you're immediately greeted by 2 options. You can either log in as a contributor or as a lead maintainer. For contributors, we basically just help them make PRs, get issues, and it's just a much cleaner way of understanding the repository and making PRs to improve the open source ecosystem. And then as a maintainer, that's our actual main job, where the maintainers can see the PRs, see if there's any malicious code in them, and I'd like Aaron to talk more about the demo now.
Yeah, so as we were ideating, we were talking to Professor Mars about kind of like if there were any tools that were existing for Jack, and that kind of led with Yush's problems. We kind of led to us developing Ghostwatch. So we wanted to use Jack to its fullest extent and test all of its flagship AI, flagship features. So I'll talk a little bit about that. So you can see here that I can show you our repo. Our repo is built entirely in Jack, so we want to demonstrate every single feature. And being that our tool is a repo protection and defense monitor, what better way to test it than on our own repository? So it's live right now, and it's basically has all the files on our thing. So basically what happens is we have a Jack connected to a GitHub repo, and it will do a Walker traversal between all the nodes, which we make in files, we add metadata, and then we kind of label all of them here. So you can see this is every file we use. There's 116 files, I think, scanned, 60 links mapped. You can see a lot of MD files. But you can see some vulnerabilities that we can check. So we want our kind of agentic AI to be dual pronged, and one of the things is proactive. So we wanted to measure PRs and kind of evaluate what could happen, how it could affect the code base with this graph-based tooling. If you guys have heard of Murofish, it's kind of an AI agent swarm, and it's one of the biggest repositories in last month, I think. We kind of extended off of that idea. We have 3 specialties which we use by LLM calls. We have a security one, we have a capability, blast radius one, and a architecture one as well. So I want to kind of demonstrate. We can do analyze. So our first PR analyzer here. So it goes through all of the code, and it basically maps out all the walkers. And then once it's done, we can see that it pings a Discord. So a lot of open source projects use Discord as their kind of a communication. So we can see we hooked up our own Discord here, and you can see PR analyzed. So the second part of our dual prompt system is kind of the malicious network tracker. So we kind of had this running in the background as we were developing. We were inserting malicious code to test it, and it was all out of the loop. And basically it has all of this. It was kind of running as we were doing it. So you can see a lot of dependency issues. You can also see contributor suggestions, which is another feature. Going back to here, going back to our app, we can see basically how we differentiate is how we use Jack to the fullest extent. Sorry, can you zoom in? Yes, and you can see here package.json just kind of sucks if you contribute that to a PR. But basically, we can have a reactive out of the loop and kind of just every few hours check. And I want my partner to talk about how.
So I can also talk about the after PR stuff. we run a cloud compute sandbox to just imitate whatever happens in the repository. And if there's any malware, any like malicious intent in there, it immediately just rolls back on it. And so I wanted to get back on JacHacks thing. When they sent the PR, it wouldn't take 2 weeks anymore. You just log in immediately. We would have everything set up for you already. Is it good? Is it not? What can it do? Does it have malicious code or not? We would check that as well. Through sandboxing and everything. So it would be like fully secure. And I just wanted to take just 1 second to talk about tech stack as well. We have E2E for the cloud computing sandbox. We have webhooks for GitHub and Discord, and we use an Anthropic API key for the agent orchestration. And we use Cloud Code with superpowers in the Jack MCP, which helped a lot.
Cool.
Thank you. Any questions?
Thank you.
Very cool, very cool. So, I think the journey you guys took for implementing in Jack is a really common journey. So I mean, it's kind of like, I think it's maybe a prototypical journey of how you set things up. I'm wondering what your honest thoughts were with the language, given you've worked with many open source projects and so forth. What's your review? Your GameSpot review?
Honest review? Yeah. It's a really good language, don't get me wrong. It's just not mature enough right now. I try to use JackCoder. I have an old Intel. It just doesn't work because it doesn't have support with Intel Max. So I think with a lot of open source repositories, if you see the ones that are the classic ones, like frameworks or databases, they always have a backwards compatibility. You can run them on 20-year-old ThinkPads as well, Whereas in Jack, I feel like that was a really huge constraint, and both of our computers were running fans. It was like an airplane going off in the room. It's a quite heavy language, but it's really good with much more maturity. It will be a really good language, and we also discussed this in other hackathons. We might actually also use Jack, so it is a good language, yeah.
So like Ayush mentioned, we use superpowers as the framework, and it worked really well with the MCP. So one of the things we're testing, test-driven development, is something very big. And Jack is the JacChack thing, right? You can check the code and check for everything, and that was super easy to test everything. And also the file size was so much easier to organize. It's 4 times smaller code base than what we could have done with you can see 116 files. It's already a huge project. It would have been way worse with React Fast API.
Cool.
Any other questions?
You mentioned about Axios, right?
Yeah.
But the maintainer account was hacked and taken over and then published. It was not a single PR.
But the PR would never even go through if you had the sandbox in place.
No, he already
He
owns
sent a
maintainer's
PR.
account, right?
He sent a PR and he accepted it himself. With our sandbox in place, he wouldn't be able to do that. It would have to go through the sandbox. I know exactly what happened. The maintainer was hacked, and then they pushed the code through, and they fixed it, I think 2 or 3 hours later. I was following that, actually. So any PR that goes through an open source sense, it always goes through the sandbox. There's no way you can bypass that. It's not under the control of any single individual. It has to go through that, even if you're the owner of the repository. Because even as an owner, sometimes you can push ENV keys and whatnot, So that just saves your entire repository. Just makes it even more safe.
I see you have a suggestions tab. Is that coming soon, or is that there's something you can fill in?
We do actually have suggestions. Yeah. So for suggestions, because this is on the contributor side, how every single open source repository already has issues they want solved. We have those, we scrape them off, but we also have recommendations by our AI. So every time we run sandbox checks, there's another agent that checks what more can we add to this? What can be better in this? What are the bugs that haven't been fixed yet? And then it gives recommendations by AI, and you can pick those up as well.
So what's great about object special programming is as it traverses, it can kind of see the gaps and catch up on that, which is kind of not able for other languages to do.
And this will be fully open source, and I hope to contact all my friends to use this in actually open source. Because I use the Django one, and I hope to never use it again. It's really bad. Especially finding issues to work on, it's really bad. So yeah.
Cool. Thank you so much.
What are you going to open source it?
Yeah. Let's go.
We have to work on the maintainer side a lot because there's also the permissions issue with GitHub. So once we figure that out, it will be open source soon.
Okay, cool. Thank you so much.
That's kind of relevant to questions that honestly doesn't.
Somewhere to go.
We need to leave town to travel out of hackathon, yeah. So we need to actually run this.
And then
That's
within
fast.
the Q&A to judges, if you have other questions or if you're interested in projects, feel free to catch
But everyone who actually, presented or will present, please submit something on I built this, because I think those are really good projects. It'd be great for the broader ecosystem to see your stuff.
So, hello guys, I'm Sanat, and I'll be presenting to you Orbit. So, I was doing this solo, so excuse me for not having a slideshow. My demo is my presentation. How many of you guys been in a movement where you're studying something and you realize, oh, this is a concept from my other class. Like I was just studying this in my other class or any other field. That instance, that is learning. Those connections between those dots, those two different instances, that is learning happening. But the thing is, it happens so randomly. It happens when you least expect it. So Orbit makes it happen on demand. It connects those dots as you want them to. This graph that you're seeing is my knowledge. And it has 125 concepts, 100 which are the nodes, and 363 connections, which are the learnings that I'm talking about. So what's going on here is that the first cool thing is I coded it using Jack, and I used walkers. The first walker is a path explorer walker. It explores the path. Let's try asking it a question. So right here, let's be like, how is music theory connected to empathy? Two very different nodes. Oh, ooh la la. Let me reload that and try that again. Perfect. Is music theory connected? I can't see.
Oh, you want a mirror?
I would really appreciate that.
Yeah, let me help you. Get the mirror and I feel you. I've been here as a teacher. Yeah, that's hard. That's a hard thing. So you just change this, you do the entire screen.
Yeah, I
start
can't see
here,
that. It's fine.
and then, unless you wanted to, is that okay?
Oh, it's not showing me anything.
Oh. That's showing. Here, I don't get the private stuff. Where is it? Oh. So is it one of these?
No, it's. Wait, can you go back to the?
Yeah.
I think. Sorry, guys.
Sorry about this. Bye.
Oh, perfect. So,
oh yeah, we got it.
Wait, no, first, okay.
My bad. Keep pausing stuff.
Okay, let's continue that. Music theory, like I was saying, is connected to. It's connected to empathy.
Music theory.
Okay, perfect.
I got it.
So, now the Pathfinder Walker that I implemented using Jack, it traversed the entire graph and it found those two nodes, music theory and empathy, and it connected those graphs. and here's the path. Mind you, these were nodes that were already in your brain, like pieces of information. So it went from empathy to mentorship, growth mindset, brainstorming, improvisation, and music theory. And it also calls a LLM call, like to Grok, because it was free. And it explains how those two concepts are connected. Let's try something else. Our brain is not a constant. We keep adding information, and let's try adding some information. Jason Mars is a great guy.
Thank you.
So let's ingest that knowledge in our brains. Okay. Perfect. So new nodes are being made, and so this ingester walker, it traverses across the path and then connects the old concept, the old nodes, to the new ones. Now, you guys remember how I was talking about how you're studying a concept and then you realize, oh, this is something that I was already studying. Let's surprise ourselves. Let's do
Well, we can do questions. Is that fine?
I think we can kind of, I was getting too long.
Yeah. Oh, yeah, we're gonna put it down.
Yeah. So let's surprise ourselves. So, perfect. What surprised me did was that this Explorer Walker that I implemented using Jack, it took two random nodes in the brain, two random pieces of information, and it found a path between them, completely unrelated pieces of information. And it found a path between them, and it then explained how those paths were connected to each other using the by LLM code. So this is very interesting. How is it different from Obsidian or Notion or other Apple Notes or other note-taking apps? Those apps, they store your notes like filling a cabinet. Orbit connects and makes sense out of those notes. So yeah, that's how it's quite different. And how is it different from ChatGPT or other LLMs? Is that ChatGPT knows nothing about you. Orbit knows only about you, so it only works within your knowledge space. So yeah, thank you.
Yeah, so one thing I really like about this is it feels like a very original idea. And it's a nice, it's great to see how you've used so many different features. How did you come up with the idea?
So when I was looking through the documentation of Jack, it was very interesting to me how the graph and the nodes, the entire ecosystem was built into it. So the first thing that came into my mind was connecting dots. So it was a very natural thing how we could work with Notion and softwares like that to make them more AI based and more interactive and make more sense out of the things that you already have. So yeah, that was my way of coming up with Orbit.
Yeah, I don't have a question, I just have a comment. I think this is really cool. I think this is something that a lot of people don't even realize they need because they feel like they know a lot of things, but it's actually a mess. Earlier you were what's the difference between this and Obsidians? And I mean, I think another way if you want to sell this, right, it's this just sits on top of Obsidian or wherever you keep your knowledge, right? Obsidian it is a file cabinet, right? They have some linking, but at the end of the day, it's flat and it's a hierarchy. So yeah, great idea.
Yeah, so I was also if I was to go ahead with this project, adding Obsidian importing to this on top of this, importing all of your notes from Obsidian or Apple Notes or any of those note-taking softwares would be, I think, that's my next step for this.
Cool, thank you so much.
Thank you.
Yeah. Okay, all right, cool.
Yeah, we don't have a closing statement, we have to decide. Yeah. I'm stopping.
Thanks everybody for being so patient. We're gonna accelerate the closing ceremony because we want to finish within a band. of time, so we're going to do our best to accelerate it. So we don't plan to keep you too much after the planned end of the hackathon. So thanks for your patience.
Amazing project so far. Thank you, guys.
Sold. It's under. That's Windows, right? No, that's Linux.
Linux.
Oh, there we go. That's good.
Send me that distro, it looks nice.
Oh, sure.
Okay, so I'm on board with this. Okay, this is gonna.
Do you need a mic? Oh, okay, all right.
Hi, everyone. My name is Jaseci.
Turn it on, there's a flip. Yeah, you got it.
Okay. Hi everyone, my name is Shazib and this is Matters, and we build spatial mind for you guys for this hackathon. So we interact with physical spaces every day, our homes, our offices, warehouses, and you can show ChatGPT for a photo of a room and it will describe what it sees, but ask it where the lamp was last Tuesday, or navigate to the bookshelf, or tell you what changed since yesterday. It has no answer, because it can do 3D modeling for you guys. Because today's AI has no spatial memory and it sees, but it doesn't understand. So that's the problem spatial mind solves. We give AI a persistent, queryable, understandable of a physical space, not just as a description, not as a photo, but as a living knowledge graph that agents can reason over, navigate through, and remember across time. So we use Jack Walker's intelligence as our AI in the backend as our main AI intelligence to actually walk through the photos as graphs and then give you the outputs that are needed. We believe that this is going to be quite a big market, which is projected to be around $1 trillion spatial reasoning by 2034. And all of those all of the AIs that are out there are just solving pieces of the puzzle. None of them have built what we've built, a knowledge graph that AI agents can actually reason over. And we believe that that's the missing piece that we need right now in this AI space.
Yeah, exactly. So, so today you've seen many presentations, right? And there's like a recurring theme with these nodes, right? And they've all been with 2D, right? And like the whole idea about Jack is it's time for a new language, right? But that also begs the question, isn't it also time to go away from old 2D to new 3D? Because like we live in the 3D world, we don't live in the 2D world, right? So bringing tools into the 3D space is really the future. And I think the first company to actually crack this is gonna have a lot on their hands. So the way we approach this is with Gaussian splatting. So I just want to quickly go over what it is. Like, so if you guys didn't know, just for a quick understanding, it's just a Gaussian 3D object. So it's imagine like a 3D ellipsoid in space somewhere. So it just looks like that. It has like an X, Y, Z coordinate and an opacity, which is like how much light it lets through, right? So it's pretty simple. That equation looks complex, but it's not as bad, right? And then if I go to the next slide here. So what we did is we had an agentic reasoning loop over our thing. So basically we create a 3D Gaussian splatted 3D model of anything you want, right? So you can walk a video, go through whatever you want. And we always start with a natural language request. So you can say, make the couch blue, or find the person, or highlight his hand left, or how many feet does he have, or something like whatever, right? Anything that you need to do, and it goes into this Gemini agent orchestrator, right? Which is all powered by Jaseci, right? So what it does is it first parses your intent, picks the tools and arguments that it needs to use, observes the result. So and it goes into this reasoning loop. So it can call tools like find splats, highlight splats. It can recolor them, move them. So in the future, we want to be able to edit 3D scenes as well. So the way we train this is we had to do a lot of machine learning on Google Colab, right? So we had to capture this, first capture the video right through the camera, put it into a 3D Gaussian splatting module, right? Then use SAM and clip to extract the embeddings, train an autoencoder for the compression to 5 total 3 dimensions, whatever. And then at the end, we get a semantic Gaussian splatting. That's the main thing. That normal Gaussian splatting doesn't have any meaning. You can't query about anything. It doesn't know about what it is, right? It's just a model. But this turns just the model into something that you can actually, like, it knows what it is, right? And then the query flow is just like, again, the user inputs something, right? The clip text encoder turns it into a format they can accept. It decodes it, so it takes the small 3-dimensional vector into a big one, so it can query. It uses the relativity score, and it shows us the spots you want. So I'm going to go with all this technical jargon because this is like not that much fun. So let's look at like some models, right? So this is our first kind of iteration that we looked around. So we walked around like a room at UMich, right? And this was like a maybe 30-second video, and like it's pretty bad, but like you can just do a lot of stuff with this. So you can like fly through, you can see like all the chairs here, right? If you could go up, it's like a whole 3D interactive thing. So if you train this more, you're gonna have a much better result, which we will show in the next slide that we actually got a much better result on this. But this is like our first kind of standing point, right? And then the next slide, you can see that this is where we kind of ended up. So this is my partner Shazim. He kindly volunteered for this experiment, right? So he's here, and maybe it was like a 30-second video. So that's all this took, right? And I got this 3D model. I can zoom in on him, zoom out, do whatever I want, right? This is a complete 3D model of him, and of course there's the Gaussian splatting is weird, so you can't go in the back of it because it didn't see what's behind the wall, right? So you got this whole 3D model, and now let's look at the semantic layering, because that's like the really interesting part, right? So you can see this little pink thing here. You see this? Because look at the question, find the shoe. So I gave like 4 kind of questions you can do. Like this, for example, find the shoe, right? And it has a shoe highlighted in pink, right? And the next one, for example, and you can see the chat updating as well. So these are questions you can ask in natural language, right? Or find the sofa, right? So the thing with this is that it's hard to map the entire sofa because they're probability distribution. So what this shows is just like a probability of where the sofa is expected to be. But you can see that it's already kind of figuring out where it is. And this is only with a little bit of training. So with more training, this would be way better. And then you have like find the chairs, right? Plural. Hold on, it has problems with this sometimes. But you see it flickering in and out, right? So we'll go to the last one. This is find the person, right? You can see how he's lit up. There's some stuff behind him, but it's mainly him lit up. So you can see how this would be super impactful. You could be editing scenes like 3D. You could be reasoning over this. It understands where things are in relation, right? And the whole main thing stands off just like elapsed. That's like the main thing here is that all of these like Shazeb as a person is a node right now, and he has connections to his arms and legs. That's why his legs are highlighted because his legs are also human, right? Arms are human. Right? His eyes are human, his hair is, right? So it's all connected, and he has nodes that have edges that traverse to all these different points. And then there's walkers, like when you send a text like a query, it'll go and it will walk across these edges based on relevance, right? So based on cosine similarity. So it goes, oh, there's an arm, let's go head, tail, or sorry, not tail, but legs and everything, right? So it makes the whole construction. Same with chairs, same with anything you want, right? In 3D. That's the main thing, yeah.
Cool, awesome. Thank you.
So it's really cool. I mean, I love the application of how you leveraged some of that object spatial graph semantics. Did you find it intuitive applying it to this problem? Was it an intuitive? Oh, okay.
Yes. Because like I feel like 2D is like kind of like a kind of normal application, or like 2D is like the first thing you think of, but when you really think about it, 3D is like almost even better because you start to see how these connections, like that really is what connects things. Like you don't have to have like X, Y, or even X, Y, Z. You have edges, so you can just follow edges. It can be fluid. It doesn't have to have. You can go behind walls. Like what's behind the couch? It can go around, right? You don't have to have it blocking, right?
Go.
Yeah.
Any other questions?
All right, cool. Thank you, guys.
All right.
It took like 5 hours now, so it was pretty sweet. I used the A100 on Google Colab, so that's yeah, I know it was wow. It was 5 hours. And so it was pretty cool, yeah. So it was great. I know, right? Oh, quiet. See if people saw it. Yeah, I think we should.
So the project I worked on was a dev tool, and it is a command line interface extension. So the project I worked on was a command line interface tool to add on to the existing JacHacks system. So I can get started with a demo to illustrate what I've made. If you look at the top file up here, the important thing for the demo is knowing that I have an item defined up here and it has one attribute, and I'm trying to print out that attribute later down in the file. So if I go ahead and run that file, we can see that the attribute name got printed. But say I want to update this file. In version 2 of the app, I go ahead and add an additional attribute to the item. And again, I'm printing all the attributes under the item. And go ahead and run version 2. We see that it throws an error because the new attribute isn't in the stored values for the item node. So the issue here is the stored values for all the previous items before we started running version 2 only has a single attribute, and it won't be compatible with the version 2 unless you go ahead and manually edit the database or go ahead and delete the database and start from scratch. So what I decided to do was to create a command line interface that takes those previous items that you've defined and allows you to add null values or default values to make it so previous data is still compatible with future values. So the first command will be jack migrate status, and we just want to run this command to make sure that we have an active database, and because it exists, we can go ahead and continue with the rest of our demo. So once we know that we have a database that exists, we can generate, do migrate generate, and what this does is that it creates a file that identifies all the necessary empty attributes from previous entries. So here we can see that I found a difference in version 1 and version 2, and it stores the value locally. And then once we store the value and generated that doc, we can apply it, and we can output that we have one update. So with that update, we can finally run version 2 once again, and this time is able to print the second attribute, even though it was defined in the second version. And currently, it is just filling in null or default values for attributes that are missing, but a future extension of this would be to connect it to an LM or connect it to an agentic application that predicts what the missing value should be when you do update it, since this is a relatively basic demo, and in reality, you're going to have far more attributes and far more nodes when working with a real world application. Yeah.
This is awesome. This is a great contribution. PR? Yes, please make, we would welcome that PR. This is a roadmap item that should be there, right? And so, but it's awesome, super useful. Any other? Cool, awesome, thank you so much.
That concludes the presentation, and I guess we're gonna take 5-10 minutes.
You want to see you want to go outside?
Yeah.
Yeah.
The judges
Okay, you guys
will-
can sit here.
We're kicking ourselves
We'll
out
do a
for 5
quick
minutes.
Committee
And then we will be back.
discussion. All right.
Right.
You guys can come to